Hi everyone, welcome to my YouTube channel Edu-spectra. So in our previous class we had learned about properties of certs. So now in this class let us start with the exercise number 1.5. Okay, so the first question that we are having here is classify the following numbers as rational or irrational. So let us see. Our first question is 2 minus root 5. So in our previous class we had learned whenever we are doing a rational minus an irrational number, it will always be a irrational number. Otherwise also root 5 has a non-terminating, non-recurring decimal expansion. Okay, so 2 minus that is always a non-terminating, non-recurring decimal expansion itself. So we can write this as a irrational number. Okay. Now the next one is 3 plus root 23 minus root 23. Okay, we know. Just see over here, we can write this as 3 plus root 23 minus root 23. Root 23 minus root 23. Whatever inside the roots are similar. So we can just subtract it. So root 23 minus root 23 is 0. So 3 plus 0 is 3. Okay, and we know 3, we can write it as 3 by 1 in p by q form. So our second one is a rational number. Okay, our second one is a rational number. Okay, now the third one is 2 root 7 by 7 root 7. So here just see, here we can just cancel off this root 7 and root 7. So we will get our final answer as 2 by 7. So what is 2 by 7? We know 2 by 7 is a rational number. It can be written in the form of p by q. So our third one is also a rational number. Okay. Now the fourth one is 1 by root 2. So in our previous class we said never in the denominator root of something can be present. So what should we do? We have to rationalize the denominator. How will you rationalize the denominator? Multiply and divide this denominator root 2 with this number. So when we do, what will we get our answer? 1 into root 2 is root 2. Root 2 into root 2. Similar roots when we multiply, we will get whatever is inside the root. So we will get our answer as root 2 divided by 2. And we know root 2 is irrational by rational. Always irrational by rational is always what? Irrational number itself. Okay, I hope I am clear. Irrational by rational is always irrational itself. Okay, now the fifth one is 2 pi. We know pi has the decimal expansion 3.14 and it goes on like that. Okay, so this has a non-terminating, non-recurring decimal expansion. We are multiplying it with 2. So definitely this 2 pi will also be having a non-terminating, non-recurring decimal expansion. So this also will be an irrational number. Okay. Okay, so now let us move on to our second question. The question is simplify each of the following expression. Okay, so the first question is 3 plus root 3 into 2 plus root 2. Okay, so here we can see our identity, that is a plus b into c plus d, which is your dancing queen identity, that as I have told you. Okay, so you know how to expand this identity. First of all, what should we do? We have to fix this 3. After fixing this 3, multiply this 3 with this 2, just like we are dancing. Okay, then this 3 with this root 2. Then after that, so let's see. First of all, 3 into 2 plus this multiplied with this plus 3 into root 2. This multiplied with this. Okay, then plus, then what should we do? We have to fix this root 3 and multiply this root 3 with this 2 and this root 3 with this root 2. So plus, we can write root 3 into 2 plus root 3 into root 2. Okay, now we can just simply solve this and do. So 3 into 2 we know it is 6 plus 3 into root 2 is 3 root 2 plus here also 2 root 3 plus this is root a into root b. Root a into root b is equal to root of a into b. So here also you will get 3 2s are 6. Okay. So this is your final answer. 6 plus 3 root 2 plus 2 root 3 plus root 6. There is nothing common here. The root under the root it is 2, here it is 3, here it is 6. So we cannot add and do any further simplification. So this is your final answer. Okay. Okay, so our next one is 3 plus root 3 into 3 minus root 3. So this is our question. Now here if you see what is the identity that we have to use. The identity that we have to use is a plus b into a minus b. So 3 we can take it as our a, root 3 we can take it as our b. Okay. So we know a plus b into a minus b is a square minus b square. So how can we expand it? So first of all a square I am writing it as 3 square minus b is what? Root 3. So I can write it as root 3 the whole square. So we know 3 square it is 9 minus root 3 the whole square means simply 3. So we know 9 minus 3 is what? 6. Okay. I hope I am clear. Here we are using a plus b into a minus b identity, that is 3 square minus root 3 the whole square. Root 3 the whole square means 3 into 3. So we will get our final answer as 9 minus 3, 6. Okay, now let's see our next question, which is root 5 plus root 2 the whole square. So here also we know our identity, that is a plus b the whole square. So here we can take root 5 as a and root 2 as b. And we know a plus b the whole square is equal to a square plus b square plus 2ab. So we can just expand it and go. So first of all we can write root 5 the whole square plus root 2 the whole square plus 2 into root 5 into root 2. Okay, so we know root 5 the whole square means root 5 into root 5. So that is simply 5 plus root 2 into root 2 is simply 2 plus 2 into root a into root b is equal to root of ab. So I can write 5 into 2, 10. So 5 plus 2 we know it is 7 plus 2 root 10. Okay, so this is your final answer. Okay, so now our fourth subdivision question is root 5 minus root 2 into root 5 plus root 2. Okay, so here also if you see, we can see our identity a plus b into a minus b. So a plus b into a minus b is a square minus b square identity. Okay, so we can use our identity. So I can write it as, I will take this as a, root 5 as a and this as b. So a square, root 5 the whole square minus root 2 the whole square. Okay, so root 5 the whole square it is simply 5 minus root 2 the whole square it is simply 2, and we know 5 minus 2 is what? 3. Okay, so this is your final answer. Here we are using our identity a plus b into a minus b, that is a square minus b square. Root 5 the whole square is 5, root 2 the whole square is 2, so we will get 5 minus 2 as 3. Okay. Okay, so now let us move on to our third question. This is a very interesting question. Just see. Recall pi is defined as the ratio of circumference of a circle to its diameter, say d. This is pi is equal to c by d. This seems to contradict the fact that pi is irrational. How will you resolve this contradiction? Okay, so this is your question. So basically, first of all, we get into our question. Let us understand a few things. We know this is a circle, and we are from the distance from the center of the circle to the boundary of the circle is what we call it as radius. Okay, from this side also we can draw a radius. There can be infinitely many radiuses being drawn in a circle, and one full distance, that is from here to here and here to here, that is 2 times of radius. We can call that as the diameter of the circle. Okay, so from here we can write 2 times radius is equal to diameter. Okay, then also I hope you know what is circumference meaning. Circumference means the boundary of the circle. What is the total measure of the boundary of the circle is called as the circumference. Okay, another word that we use for the circumference is perimeter. Okay, in your class 8 you have learned about perimeter and area and all. Perimeter means the boundary, area means the inside region. Okay, perimeter is the outside measure of the circle. Okay, so I hope I am clear. So last year you might have learned the perimeter of a circle, or the circumference of a circle is equal to 2 pi r. The area of the circle is pi r square. Okay, now just now question they are asking you about circumference. So I wrote circumference is equal to 2 pi r. So now what can I do? I am keeping this pi over here. Okay, and I am bringing this 2 and r to the other side. So here I am having C. When this 2 and r goes to the other side, it will come to the denominator. Now I told you what is 2 times radius? 2 times radius is diameter. So we will get pi is equal to C by D. Okay, this is what is given in your question. That is, pi can be written as circumference divided by diameter. That is the thing which is given in our question. Now, if you see over here, you see pi is equal to C by D. Actually, what is it? This is actually a P by Q form. Okay, so if we can write pi in the form of P by Q, that is in a rational form, then how can we say that it is a irrational number? That is the contradiction they are asking. A contradiction, or you can call it a paradox. Okay, even though if we can write pi as C by D, then why are we calling pi as a irrational number? So let's see. Actually, basically if we see, there is no contradiction at all. When we actually expand this 22 by 7, we are not getting the answer is 3.14 itself. It goes on like this. It goes up to a million trillion decimal places. Okay, this 22 by 7, 3.14, we are taking it as an approximate value only. If you see the original value of 22 by 7, it is 3.1415926, it goes on like this. That is basically it has a non-terminating, non-repeating decimal expansion. So we know if a particular number has a non-terminating, non-recurring decimal expansion, it definitely will be a irrational number. That is the reason why we say pi is, even though pi is equal to circumference by the diameter, when we do the decimal expansion, we are getting a non-terminating, non-recurring decimal expansion. So definitely it will be a irrational number. So you can write, there is no contradiction. 22 by 7 is an approximate value. When we do the value, we will get the non-terminating, non-recurring decimal expansion which goes up to millions and trillions of places. So definitely pi is an irrational number. Okay, I hope I am clear. Now the fourth question, that is represent root of 9.3 on the number line, that we will be doing in another video. Okay, so now let us move on to our question number 5, that is rationalize the denominators of the following. Okay, so our first question is rationalize 1 by root 7. So we know the concept, whenever there is in the denominator a root of something, we have to eliminate it. So how will you eliminate this root 7? We have to multiply and divide this number with root 7. So 1 by root 7 into root 7 by root 7. 1 into root 7, you know it is root 7. Root 7 into root 7, it is what? Simply 7. They are two similar surds. Okay, so this is your final answer over there. Multiply and divide with the similar number. Okay, so now the second question is 1 by root 7 minus root 6. Okay, so here if you see, here also in the denominator there are root numbers, but in between there is a negative sign. When I am told you, whenever there is a negative, positive something, when it is a little complicated type of roots, we have to always multiply and divide it with the conjugate. So what is the conjugate of root 7 minus root 6? The conjugate is root 7 plus root 6. Okay, so let us write 1 by root 7 minus root 6 into root 7 plus root 6 divided by root 7 plus root 6. 1 into this thing is simply root 7 plus root 6 divided by So here if you see the denominator, it is a minus b into a plus b, or a plus b into a minus b is what? A square minus b square identity. So I can write over here root of 70 whole square minus root of 16 whole square. So I can write root 7 plus root 6 divided by root 70 whole square means root 7 into root 7, which is simply 7, minus root 60 whole square is 6 root 6 into root 6, which is simply 6. So 7 minus 6 we will just 1. So we will get our final answer as root 7 plus root 6. Okay, this is your final answer. That is root 7 plus root 6. Okay, next one is 1 by root 5 plus root 2. So here also it is, there is a plus sign in between. So whenever plus sign is there, multiply and divided by the conjugate. So 1 by root 5 plus root 2 into root 5 minus root 2 divided by root 5 minus root 2. So 1 into anything is that same thing. So root 5 minus root 2 divided by, in the denominator again, a plus b into a minus b identity. So we know a plus b into a minus b is a square minus b square. So from here you will get root 5 minus root 2 divided by root 5 the whole square, it is simply 5, minus root 2 the whole square, it is simply 2, and we know 5 minus 2 is 3. So we will get our final answer as root 5 minus root 2 divided by 3. Okay, this if you want can also just split it and write it as root 5 by 3 minus root 2 by 3. Okay, either way you can write. So this is your final answer, that is root 5 by 3 minus root 2 by 3. Okay, I hope I am clear. Now our next question is 1 by root 7 minus 2. So here also we are having a negative sign in between. So we have to multiply and divide it by the conjugate. So 1 by root 7 minus 2, multiply and dividing it by the conjugate. Okay, so plus 2 divided by root 7 plus 2. So 1 into anything it is that itself. So root 7 plus 2 divided by, again in the denominator it is a plus b into a minus b identity, which is a square minus b square. So root 7 the whole square minus 2 square is equal to, here root 7 plus 2 write as it is divided by root 7 the whole square means root 7 into root 7, which is simply 7, minus 2 square means it is 4. So here we will get root 7 plus 2 divided by 7 minus 4, it is 3. Okay, so this is your final answer. Always multiply and divide it by the conjugate. Conjugate means plus becomes minus becomes plus, plus becomes minus. Okay, in this way you can rationalize the denominator. Here also if you want you can split this and write it as root 7 by 3 plus 2 by 3. Okay, just splitting the denominator and writing. Either way it is correct. Okay, so I hope I am clear. Okay, so now we have completed all our questions in exercise 1.5. So I hope I am clear with it. So now we will meet in another video. Till then, thank you. Please like, share and subscribe.